Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, Episode 6 of 24. What if you could migrate your entire user base from OpenAI to Anthropic without asking them to update a single line of their integration code, or quietly switch a free tier user to an open source alternative without breaking their existing application logic? The mechanism that makes this silent transition possible is called Model Aliases. It is easy to confuse aliases with routing, so let us separate the two. Routing handles load balancing across multiple deployments of the exact same model. If you have 3 separate Azure OpenAI instances running the same version of GPT-4, routing distributes the incoming traffic evenly among them to prevent rate limits. Aliases do something completely different. An alias intercepts a requested model name and maps it to an entirely different model behind the proxy. You apply this mapping at the moment you create a virtual key for a client. When you send your request to the LiteLLM key generation endpoint, you include an aliases object in your payload. This object is simply a dictionary matching the model name the client will ask for with the model name you actually intend to serve. Let us look at a concrete scenario. You have a segment of free tier users. They originally built their tools around GPT-4, and that exact string is currently hard-coded into their network requests. Serving GPT-4 to non-paying users is expensive, so you decide to redirect their prompts to an internal, highly optimized Mistral 7b endpoint. To accomplish this, you generate a new virtual key specifically for this user group. In the generation payload, you define an alias that maps the string GPT-4 directly to your Mistral 7b deployment name. You give this new virtual key to the users. They do not modify their application code. They continue sending standard chat completion requests to your proxy, explicitly asking for GPT-4. Here's the key insight. The LiteLLM proxy receives the incoming request and authenticates the virtual key. It reads the configuration bound to that specific key and spots your alias role. Before it routes the payload to an external provider, the proxy rewrites the model parameter in memory. It removes GPT-4 and substitutes Mistral 7b. The request goes to your internal Mistral deployment, generates the text, and routes the response back through the proxy to the client. The client application receives the standard response format it expects. Its parsers work perfectly, and the application continues functioning normally. The developers maintaining that client application are completely unaware that the underlying language model was swapped. Because aliases are attached directly to individual virtual keys rather than the global server configuration, you maintain absolute control over different user segments. One key can alias traffic to a cheaper model for free users, while another key allows premium traffic to pass through unmodified. You can also use this exact same logic to handle model deprecations. When a provider retires an older model, you simply alias the old name to the new version, saving all your clients from having to push emergency code updates. The most powerful aspect of a model gateway is not just managing network traffic, but decoupling the expectations of the client from the physical reality of your backend architecture. Thanks for listening. Happy coding, everyone.